Welcome to Across the Globe. Today we will learn about profiling and performance tuning. Profiling is the process of analyzing code performance to uncover bottlenecks and areas needing optimization. On the other hand, performance tuning involves making modifications to enhance the speed and efficiency of the code. For instance, if an e-commerce website experiences slow loading times for product pages, profiling can identify the specific functions or queries causing delays, while performance tuning could involve optimizing database queries or caching commonly accessed data to improve page load times. Profiling tools such as cProfile and Line Profiler help measure code execution times. By using these tools, you can pinpoint functions or loops that are causing delays in your code. For instance, if you have a slow function in Python like the one provided, which iterates over 1,000,000 times, using cProfile can show you the time consumption of that specific function. This can aid in identifying areas where optimization is needed to improve the overall performance of your code. To improve computational efficiency, it is crucial to optimize algorithms and data structures by reducing their complexity. Unnecessary I/O operations should be minimized to enhance performance. Leveraging built-in functions and libraries can expedite execution. For instance, in Python, optimizing a function can be achieved by employing list comprehension instead of traditional looping structures. This replacement streamlines the code, making it more concise and efficient. Profiling and performance tuning play a crucial role in enhancing code efficiency. By pinpointing and resolving bottlenecks, developers can notably boost the speed and performance of their applications. Leveraging profiling tools like Chrome DevTools or Apache JMeter, along with optimization techniques like code refactoring and algorithm efficiency enhancements, ensures that code operates seamlessly and effectively. For example, identifying a specific database query as a bottleneck and optimizing it with indexing can significantly enhance the overall performance of a web application. Profiling is like monitoring your car's fuel efficiency and engine performance to identify areas where you can improve and optimize its performance. Performance tuning is like tweaking the engine and adjusting the tire pressure to maximize the car's speed and efficiency on the road. In a computer program, profiling involved analyzing the program's execution to identify bottlenecks and areas of inefficiency. Performance tuning in a program involves making changes to the code or configuration settings to optimize its speed and resource usage. Just like with a car, regularly profiling and tuning your program can help ensure it runs smoothly and efficiently. Hey, Code Conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code snippet provided is a Go program that showcases the application of profiling and performance tuning in software development. It starts by defining a recursive function factorial that calculates the factorial of a given number. The main function then utilizes the cProf package to profile the CPU usage of the program by creating a CPU profile file named profile.prof. This profiling enables developers to gain insight into the performance characteristics of the program and identify areas that may require optimization. The program proceeds to calculate the factorial of a large number, specifically 30 in this case, and records the time taken for this computation using the time package. The elapsed time is then printed alongside the calculated factorial result as an indicator of the program's efficiency. By employing profiling techniques such as CPU profiling, developers can identify parts of the code that are computationally intensive and potential candidates for optimization. This optimization process can involve refactoring code, employing more efficient algorithms, or parallelizing computations to enhance performance. In a real-world scenario, this approach can be beneficial for optimizing complex mathematical calculations, algorithmic operations, or resource-intensive tasks in applications such as scientific computing, data processing pipelines, or AI/ML algorithms where performance is critical for optimal system functionality. By incorporating profiling and performance tuning practices into the development workflow, developers can ensure that their software is optimized for speed, efficiency, and scalability. This iterative process of profiling, analyzing, and optimizing contributes to the overall stability and performance of the software application, enhancing the user experience and operational efficiency. One real-world example of applying profiling and performance tuning is in web application development. When building a web application that handles a large number of user requests, it's essential to optimize the code for efficiency to ensure fast response times and scalability. By using profiling tools like New Relic, you can identify slow database queries, inefficient code paths, or memory leaks that could impact the overall performance of the application. Performance tuning can involve optimizing database queries, caching frequently accessed data, or refactoring code to reduce unnecessary computations. Another industrial example where profiling and performance tuning are crucial is in the video game development industry. Video games require high performance and responsiveness to deliver a seamless gaming experience. Game developers use profiling tools like Intel vTune Amplifier or Unity Profiler to identify performance bottlenecks such as rendering issues, AI computations, or memory usage. By optimizing rendering pipelines, reducing unnecessary computations, or implementing efficient memory management techniques, developers can enhance the overall performance of the game and ensure a smooth gameplay experience for players. In conclusion, profiling and performance tuning are essential practices across various industries to optimize the efficiency and speed of software applications. By identifying bottlenecks and inefficiencies through profiling and implementing optimizations based on the findings, developers can enhance the performance of their applications and deliver a better user experience. Keep learning, stay curious, and I'll catch you in the next video.